everyone. So in the previous session I have explained the electrical properties of the materials. There are two important electrical properties of materials are there. So one is conductivity, another one is resistivity. Conductivity is represented with sigma and resistivity is represented with rho. Now to explain these electrical properties of different materials, three theories were proposed. Among them, the first theory is classical free electron theory. So, before any law is invented, so every theory made some assumptions based upon their work. Okay, so according to the classical free electron theory also made some assumptions. According to the classical free electrons theory, every electron revolves around the atom in elliptical orbits. Revolves around the atom in elliptical orbits. And the next assumption is these electrons moves inside the material like gas molecules in container. That means the electrons inside the material, they moves very freely like gas molecules in the containers. That means there is no interaction between the electron-electron. That means electron-electron interactions are considered as negligible, and electron and other lattice ions present inside the material also considered as negligible. Hence, when these electrons collides or electrons and positive ions collides, all these collisions are considered as inelastic collisions. That means no force is acting in between the electrons and positive ions according to this theory. That means these electrons are moving in uniform potential field. These electrons are moving in uniform potential field. Okay, so these are the main assumptions, and one more assumption also they have taken, that this classical free electron theory obeys the kinetic theory of gases. Kinetic theory of gases. That means when the electrons are moving inside the material, they are moving with like gas molecules in a container, and the energy of these electrons is considered as 3/2 into kBT. That means Kb is the Boltzmann constant and T is the temperature. Hence the electrons kinetic energy, that means with how much energy the electrons are moving, they are moving randomly inside the material, and their kinetic energy is considered as 3/2 kBT. So from this one you can find out the RMS velocity of these electrons, which can be 3 kBT/m. So as these electrons are moving randomly inside the material, hence the net velocity will be considered as 0. The net velocity will be considered as 0. Hence no current is produced in the absence of electric field. No current is produced in the absence of electric field, and the RMS velocity with which they are moving is considered as their random velocity. So in the absence of electric field, these electrons are moving randomly inside the crystal lattice. Because of their random movement, the net velocity will be considered as 0. Hence no current will be produced. But when you apply some electric field, that means in presence of electric field, okay, these electrons, these free electrons gains some uniform velocity. They are moving with the uniform velocity inside the crystal lattice and this uniform velocity is known as drift velocity, and this drift velocity is only in the presence of electric field. So is it clear? So these electrons are moving inside the lattice in the absence of electric field, that is the random velocity. When you apply the electric field to the material, what happens? These electrons are moving towards the positive terminal with the uniform velocity. They gain some uniform velocity, that is known as drift velocity. Now we are going to derive the expression for this drift velocity. Okay, so when the force acting on the electrons due to the electric field can be considered as minus E into E. We know this formula, F is equal to EQ. Because of this force, the electrons gains the acceleration and they are moving inside the material, and the conduction process will takes place. Therefore, minus EE is equal to, we can write MA. That implies minus EE is equal to, and acceleration we can write, they gain the constant velocity, uniform velocity, that is called drift velocity Vd. So that implies Vd is equal to minus EE tau by M. And this tau is known as collision time. Collision time is nothing but the time taken for the electrons in between any two successive collisions. So like this we can derive the expression for the drift velocity. From this drift velocity we are going to derive the expressions for current density and mobility and conductivity, and we will see those expressions in our next lecture.